Hello my dear students, today we will solve exercise 3.6 from the textbook of CBSE board NCERT Mathematics of grade 6. Okay, so let's start exercise 3.6. Here this is the first question. Find the HCF of the following numbers. Here we have to find HCF of these numbers. Some students might not know how to find HCF and LCM. For them, I had made one video on HCF and LCM. Here I explain how to find HCF, which all conditions we have to apply while finding HCF, as well as two methods I had explained here. Okay, to finding HCF and LCM. You can go through it. It will be easy for you to solve exercise 3.6. Okay, now let's solve the first question. Here the first number is 18 and 48. Here we will use prime factorization method to find HCF. So we will find the prime factorization of 18. As 18 is an even number, so we will choose the first prime number, that is 2. 2 9s are 18. Okay, 9 is an odd number, therefore we will divide it by 3 now, because 3 is the next prime number. 3 3s are 9. Next 3 1s are 3. Okay, now let's find the prime factorization of 48. Here 2 2s are 4. 2 4s are 8. Next 2 1s are 2. 2 2s are 4. 2 6 are 12. 2 3s are 6. Here all the even numbers ends. Here we got now odd number, and that is the next prime number. So 3 1s are 3. Okay, so the prime factorization of 18 and 48 is this one. Here we got 2 is common and 3 is common, right? Therefore, the HCF of 18 and 48 is 2 into 3, which is equal to 6. Okay, now let's solve the second one, that is 30 and 42. So let's find the prime factorization of 30. As it is an even number, therefore 2 1s are 2. Now we got here 1 as remainder, because when we subtract 2 from 3, we will get 1 as remainder. That we have to give to the next number. So the number became 10. So now 2 5s are 10. Okay, now we got the number 15, which can't be divided by 2 because it is an odd number. Therefore we have to check for the next prime number, that is 3. Yeah, we can divide it. Therefore 3 5s are 15. Now the next prime number is 5 only. Therefore 5 1s are 5. Okay, now let's find the prime factorization of 42. 2 2s are 4. 2 1s are 2. Now 21 is an odd number. So let's take next prime number, that is 3. 3 7s are 21. 7 1s are 7. Okay, now we got the prime factorization of 30 and 42 as this one. Now here we got 2 and 3 as common, right? Therefore the HCF of 30 and 42 is 2 into 3, which is equal to 6. Now let's move to the third one, that is 18 and 60. Okay, so the prime factorization of 18 is 2 9s are 18. 3 3s are 9. 3 1s are 3. And the prime factorization of 60 is 2 3s are 6. 0. Okay, 2 zeros are 0. Now 2 1s are 2. We got 1 as remainder, that we will put in front of the next number. Then it became 10. So 2 5s are 2 5s are 10. Now 15 is an divisible by 3. Therefore we will take 3. 3 5s are 15. Now 5 1s are 5. Okay, so the prime factorization of 18 and 60 is this one. Here 2 is common and 3 is common, right? Therefore the HCF of 18 and 60 is 2 into 3, which is equal to 6. Okay, now let's move to the next question, that is 27 and 63. Let's find the prime factorization of 27. Here 27 is an odd number, so we have to start from the next prime number, that is 3. Okay, so 3 9s are 27. Now 3 3s are 9, 3 1s are 3. Okay. Now we will take 63. As this is also an odd number and get divided by 3, it will get divided by 3. Therefore we will take 3. 3 2s are 6, 3 1s are 3. Next 3 7s are 21 and then 7 1s are 7. Okay. So the prime factorization of 27 and 63 is this one. Here we got the common as 3 and 3. Therefore, the HCF of 27 and 63 is 3 into 3 is equal to 9. Okay. Now let's move to the fifth one, that is 36 and 84. Let's find the prime factorization of 36. 3 1 it is an even number, therefore we will divide it by 2. 2 1s are 2, we will get 1 as remainder that we will put in front of 6, then it became 16. So 2 8s are 16. Now 18 is also an even number, therefore we will divide it by 2 again. 2 9s are 18. Next 3 3s are 9, 3 1s are 3. Okay. Now we will take 84. So 2 4s are 8, 2 2s are 4, 2 2s are 4, 2 1s are 2. Next 3 7s are 21, 7 1s are 7. Okay. Now we got the prime factorization of 36 and 84. Here 2 is common, 2 is common and 3 is common. Therefore the HCF of 36 and 84 is 2 into 2 into 3, which is equal to 12. Okay. Now next is 34 and 102. Okay. So 34, the prime factorization of 34, 2 1s are 2, we will get 1 as remainder that we will put in front of 4, therefore it became 14. So 2 7s are 14. Now 17 is an prime number, therefore we will divide it by 17 itself. So 17 1s are 17. Okay. Now we will move to the next, that is 102. As it is an even number, so 2 5s are 10, 2 1s are 2. Now we can divide 51 by 3. So 3 1s are 3. We will get 2 as remainder that we will put in front of 1. Therefore it became 21. And we know that 3 7s are 21. And 17 is an prime number. So 17 1s are 17. Okay. Therefore we got the prime factorization as 34 is equal to 2 into 17 and 102 is equal to 2 into 3 into 17. Here 2 and 17 is common. Therefore, the HCF of 34 and 102 is 2 into 17, which is equal to 34. Okay. Now let's move to the next one, that is 70, 105 and 175. So let's find the prime factorization of 3 of them. So first one is 70. 70 is an even number. So 2 3s are 6, 1 we got as remainder that we will put in front of 0. Then it became 10. So 2 5s are 10. Now 35 can get divided by 5 only. Therefore 5 7s are 35. Now 7 1s are 7. Okay. Now we will take 105. As 105 can't get divided by 2, so we will move next to the next prime number, that is 3. So 3 3s are 9. We got 1 as remainder that we will put in front of 5. Then it became 15. So 3 5s are 15. Now again we got 35. So 5 7s are 35. 7 1s are 7. Okay. Now the next number is 175. As the 175 won't get divided by 2, so we will move to 5 directly because it won't get divided by 3 also. So 5 3s are 15. We got here 2 as remainder that we will put in front of 5. Then it became 25. So 5 5s are 25. Now 35 we got. 5 7s are 35. 7 1s are 7. Okay. So the prime factorization of 70 is 2 into 5 into 7. 105 is 3 into 5 into 7. And 175 is 5 into 5 into 7. So here we got 5 and 7 as common, right? Therefore, the HCF of 70, 105 and 175 is 5 into 7, which is equal to 35. Okay. Now let's move to the next one, that is 91, 112 and 49. Okay. So the prime factorization of 91, as it is not an even number, we will move to the next number, that is 3. No, sorry, it won't get divided by 3 also. It will get directly divided by 7. So 7 ones are 7. We got 2 as remainder that we will put in front of 1. Then it became 21. So 7 3s are 21. Now 13 is a prime number. Therefore, we will directly divide 13 by 13 only. 13 ones are 13. Okay. Now the next number is 112. As it is an even number, let's divide it by 2. 2 5s are 10. We got 1 as remainder that we will put in front of 2. So it became 12. So 2 6 are 12. Okay. Now 2 2s are 4. We got 1 as remainder. So it became 16. 2 8s are 16. Now again 2 1s are 2. 2 4s are 8. 2 7s are 14. 7 1s are 7. Okay. Now the next number is 49. As we know, 49 is present in 7 table. So 7 7s are 49 and 7 1s are 7. Okay. So we got the prime factorization of 91 as 7 into 13 and 112 as 2 into 2 into 2 into 2 into 7 and 49 as 7 into 7. So here we got 7 as common, right? Therefore, the HCF of 91, 112 and 49 is 7. Okay. Now let's move to the next one, that is 18, 54 and 81. So the prime factorization of 18, 2 9s are 18, 3 3s are 9, 3 1s are 3. Okay. And for 54, 2 2s are 4. We got 1 as remainder. So 2 7s are 14. 3 9s are 27. 3 3s are 9. 3 1s are 3. Okay. Next is 81. 3 2s are 6. We got 1 as remainder. 2 as remainder that we will put in front of 1. So it became 21. Now 3 7s are 21. Now 3 9s are 27. 3 3s are 9. 3 1s are 3. Okay. So the prime factorization of 18 is 2 into 3 into 3 and 54 is 2 into 3 into 3 into 3 and 81 is 3 into 3 into 3 into 3. So here we got 3 and 3 as common. Okay. 2 times 3. Therefore the HCF of 18, 54 and 81 is 3 into 3 is equal to 9. Okay. Now let's move to the next number, that is 12, 45 and 75. So first we will take 12. 2 6 are 12. 2 3s are 6. 3 1s are 3. Now for 45, 3 1s are 3. We will get 1 as remainder that we will put in front of 15. So this became 15. So 3 5s are 15. Now 3 5s are 15. 5 1s are 5. Okay. Now next one is 75. 3 2s are 6. 1 we got as remainder. So it became 15. 3 5s are 15. 5 5s are 25. 5 1s are 5. Okay. Therefore the prime factorization of 12 is 2 into 2 into 3. And for 45 it is 3 into 3 into 5. And for 75 it is 3 into 5 into 5 into 5. Okay. So here we got common as 3. Therefore the HCF of 12, 45 and 75 is 3. Okay. Now here we finished finding all the HCF. Okay. So we will move to the next question. Second question, that is what is the HCF of 2 consecutive numbers, even numbers and odd numbers. Okay. So first we will find the HCF of 2 consecutive numbers. Some children might not know what is consecutive. Okay. Consecutive numbers are numbers that follow each other in order. Means the number should be in order. Okay, those numbers are called as consecutive numbers. Means the number is present next to it. Okay. So here I am taking the consecutive numbers 15 and 16. You can take any other number. It is okay. Just we have to remember that the number should be present next to that. See here, 16 is present next to 15, right? So these two numbers are called as consecutive numbers. Now let's find the HCF of these two numbers. First we will find prime factorization of 15. So 3 5s are 15 and 5 1s are 5. Now for 16, 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. Okay. So the prime factorization of 15 is 3 into 5 and for 16 it is 4 times 2. Okay. So if you look carefully, you will understand that there is no number is common. No factor is common here, right? Therefore, the HCF of 15 and 16 is 1 because 1 is a factor of each and every number. See here, the factor of 15 is 1 is the factor of 15 also and 16 also. It is an important point you have to remember that 1 is a factor of each and every number, and as here there is no number is common, 1 is common between them. Therefore, the HCF of two consecutive numbers is 1. Whenever we will not get any number as common between any two prime factorization. See here we are not getting any common, therefore we have to write directly here 1. Okay. So now we will find the prime HCF of two consecutive even numbers. Okay. So even numbers. Now here I am taking 18 and 20. See here, the an even number present next to 18 is 20 only, because in between 18 and 20 there is a 19 which is an odd number. Therefore 18 and 20 are two consecutive even numbers. Okay, you can take any two other even numbers, but just remember that it should be consecutive. Okay, now let's find the prime factorization of 18. 2 9s are 18, 3 3s are 9 and 3 1s are 3. Okay, now for 20, 2 1s are 2, 2 10s are 20 only directly. Next 2 5s are 10 and 5 1s are 5. Okay, so here we got the prime factorization of 18 and 20. Now here we got that 2 is a common here, right? Therefore the HCF of two consecutive even numbers is 2. Okay, if you take any other two consecutive even numbers, you will get 2 as the HCF. Okay, now let's move to the next one, that is odd numbers, consecutive odd numbers. Here I'll take 25 and 27. See here, both the numbers are odd, and after 25 there is a 26 which is an even number, not an odd number, and after 26 we have 27 which is an odd number. Therefore 25 and 27 are two consecutive odd numbers. Okay, let's find the prime factorization of 25. 5 5s are 25 and 5 1s are 5. Okay, now for 27, 3 9s are 27, 3 3s are 9 and 3 1s are 3. Okay, so 25 is equal to 5 into 5 and 27 is equal to 3 into 3 into 3. See here also we are not getting any number as common. Therefore the HCF of two odd numbers is also 1. Okay, so now let's move to the third question, that is HCF of co-prime numbers 4 and 15 was found as follows by factorization. Okay, this is the prime factorization of 4 and 15. It is 2 into 2 for 4 and 3 into 5 for 15. Okay, since there is no common prime factor, okay, here we will not find that there is no common prime factor, so HCF of 4 and 15 is 0. No, just now I told you that if we don't get any common factor, then what we have to write? We have to write 1, not 0. Is the answer correct? No, it is the HCF of 4 and 15 is not 0. Okay, the answer is not correct. If not, what is the correct HCF? The correct HCF is 1. Okay, what is the reason for this? 1 is a factor of each and every number, means 1 is the factor of 4 as well as 15 and it is common between them. Therefore, the HCF of 4 and 15 is 1, not 0. Okay, so I think I cleared all the questions here. If you have any doubt, you can ask me. Here the exercise 3.6 ends. If you like my teaching, then please like, share and subscribe to my channel. Bye everyone.